This tutorial is going to be really awesome. Hey everyone, I'm Samyak Agarkar and welcome to Agarkar Media Academy. This is the 33rd video in Blender tutorial series for beginners. So in the last few tutorials, we have seen a lot many stuff inside of Blender. We have learned how to keyframe, how to animate stuff, how to change the shapes inside of the shape keys tutorial, and we saw different render settings. And in the last tutorial, we also saw the installation of Blender 2.83 long-term support version. I think the 2.91 version is also out, but it is not long-term support version, so we are not going to jump onto that just as of now. So in this tutorial, as you have seen already, we are going to start the physics simulations in the tutorial series, and that is going to be really fun. Physics simulation will include fire, liquid, water flow. Then we have collisions and cloth simulations, and there are so many stuff that we can cover inside of the physics simulations inside of Blender, and it is going to be really awesome. So let's jump on to it. We have seen this video already. I'll just show you again so that we get a peek of what kind of tutorial this is going to be. So this is what we want to achieve in this video: fire and smoke. That is the aim of this video, and this is completely done inside of Blender, and it is pretty easy to do. Just the thing is, just the caveat is, the maximum work, 99.99% work, has to be done by the computer, by the laptop, by the CPU of your laptop or computer, and that is going to be really the bottleneck of the complete procedure. So this is where I was at. Let's just start a new uh, file inside of Blender. This is Blender 2.83 version, and one more thing to notice here, that I am using the Maya theme. I've already said in the last tutorial that I'm going to use the Maya theme. This is not the Blender default theme. The Blender default theme would give a selection, a orangish outline, but inside of Maya theme it gives the greenish outline. So just the color difference, otherwise everything is the same, right? Now I hate working on simulations on cube. I'll tell you why. I'm just for now just going to delete the cube, and so we delete a cube. I'm going to add a new uh, what do we call it as a new object. Let me first get myself aside so that you can see what's going on. Yeah, so shift a is for adding a cube, adding any mesh. So shift a to add, or you can also go here in the add panel, shift a, and inside of mesh I'm going to select a torus. You can choose any other shape. You can make or create your own shape also. Even the default cube is also good for this purpose, but I'm going to tell you why I did not choose the default cube. Otherwise it makes no difference at all, right? So this is our torus. I'm not going to change anything about it. I'm just going to go to the object panel right here, and inside of quick effects, here we have quick fur, explode, smoke, and liquid. So for now we want smoke and fire. So smoke involves the fire, so there's a setting for fire also inside of smoke. So I'm just going to select quick smoke. Remember, object, select first of all, select the object, select the mesh object, and inside of here quick effects panel, here we have quick smoke. And as soon as I add a quick smoke, you can see this cube has been added. And now I can tell you why I did not go for the default cube, because inside also we'll have a cube and outside also we'll have a cube. Then it makes just difficult to explain you what's actually going on, which cube I am talking about, right? So if I have a different shape, so for now instance I have here have a torus, and now here's a cube, so I can really differentiate while explaining which one is which, right? So torus is our object or the source of the flame or smoke here, right? So torus is the source of the smoke. This outline, this cube which has been added, is the domain of the smoke or domain of the fire. Now basically a domain is the bounding box of the all animations. And the timer, sorry for the timer there. um, so the domain is basically a bounding box for the simulations. Okay, you'll understand what I'm trying to say once we are changing the settings there. So The settings for this are of course inside of the physics panel, because we are doing a physics simulation, right? So just select the cube, select the domain, and go inside the physics panel right here. This one is the physics panel. Inside of physics panel you can see all these things are possible inside of physics simulations, but we have of course gone for the fluid. And inside of fluid you can see that the type is domain. As I have already told you, it is a domain. Now there are different types possible. None, basically none means no physics simulations at all. It will take no part in the physics simulation. Domain is the domain, as I already told you, sorry, that the domain is the bounding box of the simulation flow. Which one? This one, our torus one, is the flow, because from there gas or liquid or something like that will flow. Now domain type, for now I want fire, so fire involves gas and not liquid. So if you want liquid, if you want water or something else, then you can go for liquid. We are going to see this in the next tutorial for the liquid part. For this tutorial we are going to just focus on the smoke and fire. Okay, so gas. Okay, and now here we have a resolution division. Resolution division is basically the resolution of your smoke or fire. So by default it is at 30, 32, something like that. And the higher the resolution, of course, the better the quality of the fire will be. So the fire that I showed you, this fire that I've um, rendered, this was around 150 resolution, and still you can see there are some, artifacts here and there. So the smoke is not that clean, right? The smoke particles, the smoke shape is not that clean. So the higher the resolution, the longer it is going to take to render out. Okay, or not just render but also baking the animations. I've already told you. If not, I will be showing seeing what baking the animations is. Okay, so the division I'm going to just leave it at 30 for now. Time scale and CFL number, these have some things to do with it, but it would then become very advanced tutorial. So right now we are just going to leave it as it is. Okay, border collisions, we don't want it at all. Adaptive domain, I will show you what adaptive domain is. Just remember that adaptive domain is something that we want to consider. Okay, gas bounce, buoyancy density. So if you know about some physics, then buoyancy is basically how buoyancy is basically the shape of, no, the flow of gas. Okay, flow of gas or liquid. So here we have a gas, so the flow of uh, gas would be determined by this buoyancy density. It's really very difficult for me to tell you what buoyancy is unless you know some physics. It's going to be really difficult for me, okay, because we are doing physics simulation and it's completely based off of physics. So me telling you what buoyancy exactly is it's really going to be difficult. Okay, dissolve is okay. Dissolve, basically the gas goes up and then it dissolves in the atmosphere. That's dissolve. Okay, noise, so if you want some noise inside of the gas, then that's going to be noise. We have fire, and these are the things, these are the settings. You can just change it. Minimum and maximum temperature, it's given here. uh, Completely physics stuff, no need to worry as of now, because right now it's really easy and simple. I don't want to make it complicated. Okay, now cache is really important. Why? Because let's first play the this sample, then you will understand what cache actually is making the difference. Okay, let me just move myself a little bit aside so that you can see what's going on. Okay, let's just play this. And so now here you can see the fps is really low. It's 5 or 6 fps. Of course there are too many things going on my laptop, and my laptop is not that high spec, so the fps is low. Otherwise it's going to take longer time. But now once one cycle is completed, now you can see that the second time it's going to be really fast. First time you saw that it was really slow and it was really choppy, but the second time, from the second time onwards, it's going to be really fast. Why? Because the first time it actually calculated everything that was required. Okay, the flow of the gas, how it will collide with the domain, how it would react with the domain and stuff like that. So it calculated for the first time when we were playing for the first time. Okay, and all those calculations were stored in something called as a cache. If you are a science geek or a computer science geek, or you know something about computers, then you would know understand that what cache is basically a temporary memory, or a part of the disk where everything is just dumped. Okay, it is just stored for further references. Okay, so that is cache. So once it is stored in the cache, from the next time onwards when we play it, we just have to read the file, right? You don't need to recalculate everything from scratch. You just read from the file, and that's why from the second time onwards the simulation is really fast. Otherwise, if every time it had to recalculate everything, then it would be just what do you call it as waste of resources of our computer, because once it has been calculated, it should be saved, right? That is the idea behind caching. Okay, now uh, we can make some changes into this so that the complete uh, look of this domain changes, but we'll see what cache is. Okay, so cache is being saved here. So this gibberish path, you can see here the cache is being saved. If you want to upload this file to a server where render farms will calculate or render out the complete animations, then you need to store this cache onto somewhere safe, where you will have to upload the cache to the render farms. I'll be telling you all these things once we are done with the this complete simulations part. Once you are completed the simulations part, I'll tell you how to actually use these cache stores, and how to upload it onto the render farms to use it. Okay, for now we are not going to go for that. Okay, for type, here we have replay, modular, and final. So replay is basically for viewport direction. You can have a replays of everything. In modular, if we are having some caches already stored, then we can use the modular type. And for the final, when you are doing it for the final time, we need to just bake it all. It will be saved on the disk, and boom, when you render it out, when you render the animations, it will just read the data and just bake it, and just render it out, right? So we need to have here for now at the replay panel. Okay, really difficult to understand. I already told you it's simple, but it's not that simple. There are just some different stuff that's going on. Okay, now as you can see, if I just start from again, we expect that it has to recalculate everything again, and that's what we are getting. It is recalculating every render again, because we messed around with the this cache properties, right? Type of cache properties. So basically there has to be some render or refresh settings or refresh button to just refresh. There's no refresh button inside of here, and that's really sad, because every time we make some changes, we want to hard refresh everything, and there is just no way to refresh it. So if you want to refresh your animations for the simulations, you just need to go to here, go to modular or anything final, and then again come back to replay, and that would just refresh your animations. Okay, just one thing to understand, there is no refresh button. There has to be a refresh button here, but there is not, and I don't understand why, but okay, fine. So as you can see here, when we render out the animations, you can see that the animation goes just still here, and at this box it just collides and stops, right? And that's because this is the domain, right? Every simulation takes place inside of this domain. So of course we can increase the size of the domain, and that's really easy. Just select the box, select the domain S to scale, and let's say Z. In Z direction we want to scale it up, and grab, and let's just bring it upwards. Okay, grab Z, let's just bring it upwards. Okay, so this is what we want. Now if we try to play it here, right, just here, you will see that every animation has been stretched, and that's because, again, that is what I told you, it should be having a refresh button, and it is not having the refresh button. That causes a bit of a problem. Okay, so what we, again, as I've already told you, to refresh it, it's very simple. Just go to here, select modular or anything, then again go to replay, and then go back to the first setting, and now you can see it has been refreshed. It is back at its position, and now it will recalculate everything from scratch, and this is what exactly we want. And now it is really looking cool. Okay, now you can see that it just stopped here, and it not did not went till the top. Why is that? Because the animation render frames is limited right here. Here you can see the start frame and the end frame. So we are starting the animations at frame number 1 and ending at it at 50, but right here in the timeline we have 250 frames. So let's just go for um 24 times 5 because we want 5 seconds of videos. Here also we'll go for 24 times 5 because we want 5 seconds of videos. Originally I had calculated for 10 seconds of videos. This one was that I showed you, that was 10 seconds of video, but right now we're not going to go for 10 seconds. We're just going to go for 5 seconds. Okay, and let's just go back, and again we need to refresh this domain settings. Just go to here, modular, and again go to replay, and that should, you know, get the things done. Now let's just play it. Now you can see that the smoke will again go till the end, and here you can see it is now colliding till the end. This is what smoke simulation does. Now we don't want smoke, we want fire. So just select the source, which is basically a flow. Here you can see in the physics properties now, the fluid type is flow. We, for the box it was domain, now for this torus it's flow. Okay, flow type is smoke, we want fire and smoke, so fire and smoke, easy peasy, right? Behavior inflow outflow will be seeing when we will be looking at the liquid rendering, water rendering. Okay, right now it is enough. Sample substeps we can increase it a little bit to have some, some sampling. Smoke color, it's good. We don't need to go through that. Initial velocity, we can give some initial velocity to it. Let's say initial z is 1, and just select this domain, go to the end part. We are just going to refresh it, and that's the saddest part. Refreshing is not instantaneous. We need to have some work, and now you can see the flame is showing up. Just play it and you can see, wow, that looks really awesome. Of course there are a few problems, and we are going to fix it when we go for the rendering part. Okay, right now we are not going to render it out, so that's really cool. Let's do one thing. We'll just go and increase the resolutions to, let's say, something like 64, kind of a double of it, and we're just going to go to the bottom and to refresh it, modular, and replay. And now you can see the definition of the flame is a little bit better than before, and just play it to render it out, and you can see now it's really lagging, but the quality of the render, the quality of fire and smoke is really better, right? This is really cool. Let's just pause it and let's just look at some other things as well. So dissolve, we want it to dissolve. We are just going to dissolve it at the time of, let's say, in 1 second. Just dissolve in 1 second. We don't want it to dissolve very slow. Again, just refresh it, get to the first frame, and play. And now this is going to be really awesome. You can see how cool it looks, right? The complete fire fire. Let's just render it out. Let's just wait for this to complete, and we'll see what's going to happen. Okay, and now you can see how cool it looks. Of course this is not what we are going for because there is no smoke at all right now, but when we'll be rendering it out, it is going to look really really awesome. Okay, I think in the file section also we can have some settings right here to just change the way it's going to look, but okay, 0.5 let's say, and now it is going to render again. Let's just wait for a few seconds for it to complete. Okay, the only thing that you need to understand is uh, you know it is just cool, it is just awesome the way, um, so you can understand if the uh, resolution density for the domain is high, it's going to look almost realistic. One thing to notice here is that this takes a lot of time to render out and to calculate, and of course the cache size is going to be higher uh, as you go on increasing the resolution of the fire and smoke and or any simulation for that matter. Okay, so that's one part that you need to understand. Also the second part is that um, rendering it out is really 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 tough. It takes a lot of, so resolution increasing the resolution is going to also affect the render times for the animation. So um, cycles is going to be really really tough to handle this out on my laptop, so I'm not going to handle it on cycles rendering engine. I'm just going to go for ev rendering engine. It's a bit faster but not that fast also, because these simulations are a bit tough. My laptop just cannot handle, and I cannot just keep my laptop for hours for rendering a simple 10-second animation, right? So that's one of the downfalls of using this kind of simulation inside of Blender. But of course, if you're working for a big client and you can use something like render farms, you can afford the render farms or something like that, then this stuff is just going to help you a lot. Okay, so our animation is the rendering of it is complete almost. Let's now just go to the shading panel, because if you just figure out right here, if you go to the rendering panel, nothing can be seen. Yeah, that's because for now we were all working on solid mode and we were not working on the rendering part, right? So rendering is a little bit different. So we are in the rendering settings here in the shading panel. I'm just here, I'm just going to move myself aside so that you can see what's going on. uh, Transition, yeah. So this is our basic principled volume that is added here, and for the material output here we have principal volume, and inside of principal volume we have all these things stuff. All we need to do for the fire to show up is to just increase the black body intensity. As soon as you increase the black body intensity, you can see that it shows up, the fire shows up. Okay, now because the what we did was, there we just decrease the dissolve so much, so that the complete gas part is being removed. So you might not see gas right here, but otherwise gas can be seen. Okay, and I'm not just going to render out the complete what we call it as animation, because it's just going to take time and there's no point at you looking at the rendering of animation or me waiting for the animation to complete, because I've already rendered out so that you can see how animation can be seen. So what I did was, basically, this domain settings, for the domain settings I had this at resolution divisions at 150. Right now it is just at just 64, and that's less than half, so you can understand that the resolution of the fire and smoke is going to be less than half. The higher the resolution, the longer it will take for it to calculate, and of course the longer it will take to render it out. Okay, so if you are just happy with everything, just increase the domain resolutions divisions here, and just go for the type to final, and inside of final here in the cache system, final, you can see it takes a little bit of longer time to render it out. And here you just need to bake all, and as soon as you click bake all, here you can see the fluid baking has started. Now it is faster because the resolution is really high. For really realistic looking fire, I would suggest you to go for anything more than 300 resolutions, and that's, you can understand how longer it is going to take and how um, longer it is going to render, right? So but it will give realistic look. So that is what rendering is all about. And once you are done with this, I'm not going to pause it right now, but once you are done with this, everything will be ready to move. You just save your file before rendering, because always save your file before rendering, and just go to render and just render animation, save your file. I have already shown you how to save the file at some desired location, and also we have seen how to save the videos also as well. Okay, so just watch those videos anywhere, um, and that is all that we need to take. And once we have done with that, we can have something similar to this. Of course, your settings and your um, method of objects and the domain settings and everything, that is going to just add up to the changes, and that would make every spire look different. But this is what we can expect to have at 150 resolutions. At This is a 1080p frame that I've rendered out, but yeah, you can see that this portion is not that great, it's not that clear, but that's up to the render divisions, the resolution divisions. So this is all for this video. I hope you learned something great from this video, and in the next tutorial, we are just going to look at liquid simulations. Of course, in the liquid simulations as well, we're not going to look for the very high resolution renders, because that's just all about your computer taking the hit. Okay, your processor and CPU, basically cache, RAM, disk space, GPU. This all things are going to just add up to the bottleneck of the animations. But once you get the idea of what can be done inside of Blender, you will just be happy. Okay, use these things. If you do something kind of a simulation for fire, just tag me on my Instagram, Samyak Agarkar, and also on Agarkar Media Academy. Agarkar Media is the name for the Instagram account of Agarkar Media Academy. There you can tag me and just show me what you have done on this video. Okay, I hope you learned something new, and see you in the next tutorial. Till then, keep smiling and keep learning.